Now we know how to draw a diagram and find out what an image in a mirror will look like. But what if we want to be more precise? Even the straightest ruler will make errors in your measurements. So now we need to use maths to make accurate calculations. This is the purpose of Descartes' formula, one of the most useful equations ever devised for optical physics. The formula is named after René Descartes, a French philosopher. He is most famous for the saying, "I think, therefore I am." This man didn't just think, he experimented. After studying mirrors and lenses, he came up with this formula. It relates the focal length, f, of a mirror with the distances of an object and its image from the pole of the mirror. If this looks confusing, don't worry. I'm going to run through a situation to show you how to use it. Here's an incomplete ray diagram from the previous video. We have a concave mirror with a stickman on the left standing inside its focal length. His image appears on the right. It's virtual and much taller than his. Let's say the focal length of this mirror is 5 meters. The stickman is standing 2 meters from the pole. That's DO in the formula. Question: how far away is the image? What is DI? Using Descartes' formula, we're going to work it out. First, type in the formula like this. 1 over f equals 1 over DO plus 1 over DI. Use underscore marks to get those subscript letters. Now substitute in the values we know. We are given f and DO in the question. They are 5 and 2 respectively. And they're measured in meters in this case. Okay, we better rearrange this to get all the known numbers on the same side. I will type 1 over DI equals 1 over 5 minus 1 over 2. We subtract 1 over 2 from both sides to get this. Then solve the right hand side of this equation because it's all numbers we know. It's a fifth minus a half, which gives us negative 3/10. So 1 over DI equals negative 3 over 10. Wait, it's negative. It is, but that's no reason to panic. You get a negative sign because the image you're looking at is virtual. That's this image up here. When you use Descartes' formula, negative signs pop up when you have a virtual image. We have 1 over DI, but it's just DI that we want. So, now divide both sides into 1. This gives us DI equals negative 3.3 meters to 1 decimal place. Just from that number, we can say the image is virtual, which we already knew from the diagram, but also that it's precisely 3.3 meters from the mirror. Using maths allows us to be very accurate. For this I say, merci Descartes. Thank you, Descartes. We should all be grateful to this man for giving us such a cool formula to use. Now you can go ahead and practice using it and some other formulae in the following exercises. Good luck, and thanks for watching.